All right, everyone, this is what we were talking about today about velocity, acceleration, and displacement. So on a separate sheet of paper, you're going to take these notes, and these detailed notes will help you with the delta math. So let's look at a couple of the first thing. S of t, if you look on delta math, it may call it x of t, but basically they're just going to tell you that is your original function. If you take the derivative of that function, it's going to give you the velocity function. So that's the slope at any point of this function. But what it's really saying is you'll be able to find the speed and also the direction. And then if you take the derivative of the velocity function, then it'll take you to acceleration. So if you start and are given this function, if you take the derivative twice, it'll bring you over here. If you take it once, it'll bring you here. Pause the video and you can look at some of these definitions. Displacement is change in position. That just means the object has been moved. Where did it start? Where did it end? What's going on? Speed is the rate at which something is able to move. Okay, so think of a car, the speed of the car. What's the rate? How fast is it going? At what time? And velocity is giving you not only just the speed, like how fast is it moving, but also which direction. So you have to be very clear in these definitions as you do these delta math problems. And then lastly, you have acceleration. That's change in velocity, what we talked about today. And they're going to ask you, is the acceleration increasing? So if you're in the car, are you going faster or are you decreasing? So is your speed slowing down? And it can also be change in direction. Okay, so change in velocity is increase or decrease in speed or change in direction. You can pause the video, write them down, but I'm going to continue on. Okay, so the first thing it might say to you on your delta math is it might say a particle moves along the x-axis so that the time is greater than 0. Oh, so that the time t greater than 0, its position is given by that velocity function. Okay, so right now, the first thing I would do is I would always say is which part did it give me first? So right now, it's telling me that I am in the velocity function. So I'm going to circle. I'm going to say I. All right, so the first thing I would do is I would circle this because that's where they told me I'm starting. It says they gave me the velocity function. It says determine the velocity. Well, I have the velocity function. They want me to determine the velocity. So I'm just going to take that t and t equals 6 and substitute it in for the velocity function. 6 times 6 plus 50. Please watch your negatives. You see how this has a negative on the outside of the parentheses. So that's going to give you a negative 6 times 6, which is 36, plus 36 plus 50. These are going to cancel out. So we are left with the velocity is 50. That means that direction is going right because it's positive, okay? And the speed is 50, okay? Let's try the next one. Okay, so if we look at the next one, now it says a particle moves along the x-axis so that at time t is greater than 0, its position is given by this. Look how this one is different than this one. This time it gave us the velocity function, but now it's giving us the original position. So we could say that's our original function, and it says to determine the velocity. Well, in order to take the original function and determine the velocity, you have to take the derivative. So we're going to say the velocity is going to be, we're going to use power rule. So we're going to say 2 times negative 1. So it's going to be negative 2t plus 10. Okay, so we just took the derivative of the original function. If you want, you could write the function like this. okay, which is still going to be negative 2t plus 10, but you need to somewhere state where your velocity is. So you have to say the velocity is that function. So now we can substitute in our 6, okay, times 6 plus 10, and that's going to give us at time equals 6. That's going to give us negative 12 plus 10, which means that the velocity at 6 is going to be 2. So that is how you find the velocity if they give you the original function. Okay, so let's try the next one. So let's look at this. Now it's asking for the speed. Well, that's still talking about the velocity function. So it says, well, we're going to look for the speed, but we know that velocity is speed and direction. So that just means that we only need one part of what we're talking about. But let's look at what they gave us. A particle moves along the x-axis, all right? It's still given by t is greater than 0. So, they gave us the original function. So I'm going to circle which function they gave us, because they can give us this one or this one. Second semester, you'll see them give us this one. But right now they gave us the original function. It says determine the speed of the particle. Well, in order to find speed, you need the velocity function, because velocity is speed and direction. So we're going to we can say velocity is the same as taking the derivative of the function. So we're going to say 3t squared plus 10t minus 13. And now we can plug in 2. Okay. We're just plugging in 2. So 3 times 2 to the second power plus 10 times 2 minus 13. And let's finish it out. We're going to have 3 times 4 plus 20 minus 13. 12 plus 20 minus 13. So it's going to give us 32 minus 13, which means that we just found out that the velocity at 2 is going to give us 19. Okay, but we need to know the speed. So right now, if this happened to be a negative number, you would have to make it positive. So we do know that the speed is 19. If it was a negative number, you would have to make it positive, because speed is always positive, right? So if we say how fast you're going on the freeway, your speed is going to be a positive number. Okay, so let's try the next one. So on the next one, it says the particle, hold on real quick. I knew I skipped one. Okay, so we just did this one. So now let's try this one. So this one, they're still asking for the speed, but instead they gave us the velocity function. So that means you don't have to do anything. We can already find speed by substituting in the 4. So let's substitute it in. 4 to the second power minus 8 times 4 minus 28. And that's going to give us 3 times 16 minus 32 minus 28. This is the velocity at 4. Okay, going to grab my calculator. All right, so we're gonna have 48 minus 32 minus 28, and that means your speed should be negative 12. Okay, so that's not our speed. We just found our velocity. So our velocity is negative 12, but we need to find our speed. So we know that speed is always positive, so that means our speed is going to be 12. What happened? Okay, so our speed is 12. Sometimes they'll write the absolute value, like they want you to know that that means the absolute value when you're finding speed, but speed is 12. Okay. This is a 48, if you can't see that. All right, let's clear this up. All right, so now let's look at, I think we hit those. We hit speed, speed. Okay, so then you're gonna see a problem on there that says particle at rest. Soon as you see something that says particle at rest, hopefully all these different color titles, I would either highlight them in a different color just so you know where to look. But particle at rest just means when the speed is 0. So on the last problem, they gave us the time and we had to find the speed. This time, they're giving us the speed. They're telling us when speed is 0, they want to know what is the time. So that means we're still going to use our velocity function. So it means we're going to make this right here. We were given our velocity function, so we don't need to do anything, any derivatives. So we're going to say 0 equals 3t squared minus 24t minus 27. And then we're going to factor. So we're going to factor out a 3. So it's going to give you t squared minus 8t minus 9. And then you're going to say what multiplies to give you that. So we're going to say t minus 9 and t plus 1. Okay, those are the two that factor out. So we're going to use zero product property. So right here, what makes this 0? It's going to be t equals 9. And what makes this 0 is t equals -1. We know for time, you can't have a -1 second. So that means this particle is stopped. The speed is 0. That means it is not moving. That means it's no longer moving at time t equals 9. And we don't know if it's seconds or what it is, but that's the time at t equals 9. Okay, let's move on to the next one. Okay, so now let's look at this one. This says particle at rest, so let's just write that right away. Speed is 0, find t. So this is what we're looking for. Speed is 0, find t. But look what they gave us. They gave us the original function, and in order to find speed or time for the speed, you're going to need the velocity function. So we're going to say the velocity function equals the derivative of this function. So let's use power rule. 3t to the second power minus 6t minus 45. And now we can say what happens when speed is 0. So this right here, what happens when the speed is 0? 0 equals 3t squared minus 6t minus 45. Now I have to factor out a 3 again. T squared minus 2t minus 15. Okay, and then we can find out that it's going to be t minus 5 times t plus 3. Okay, so what makes the 0? All right, so we multiply that. It's going to give us -15, -3. Okay, so what makes that 0? It's going to give us t equals 5 and t equals -3. So that means that the particle will be at rest at 5, t equals 5. Okay. All right, so pause the video if you need to copy that, but we're going to move on to the next part. Okay, so let's look at the next part. Always click it so fast. Okay, so now sometimes on Delta Math, it might ask you, when is it moving left and right? And we are still talking about the velocity function, because remember, velocity is speed and direction. So right away when you hear speed, you have to think velocity. If you think about left and right, you have to still think about velocity because it's speed and direction. So they want to know, determine if the particle is moving to the right or left at t equals 3. And they literally mean like you're walking left or you're walking right. Well, we were already given the velocity function, so let's substitute it in. That's going to be negative 2 times 3 minus 3. This can give us negative 6 minus 3, which is negative 9. So that is telling us we are moving left because it is negative. If it was moving up or down, it would be moving down. So let's try the next one. If you look at the next one, now look what it gives you. It says a particle is moving. It says right here, they give you the original function, determine if the particle is moving right or left. Well, we can't find out if it's moving right or left at t equals 1 until we have the velocity function. No, okay, so all you had to do was find the velocity, negative 3t squared minus 14t plus 5, and then we just had to plug in 1. Oh, help me, Lord. Okay. All right. Plus 5 equals negative 3 minus 14 plus 5. Okay. So it's going to give you negative 17 plus 5, which is negative 12. So that means our particle is moving left. Wow. I'm not redoing this video. I'm not. Nope. Hopefully y'all skipped it. All right, here we go. Next part. Okay, then lastly, finding the acceleration. It gives us the acceleration at t equals 3. So we're just going to say plug in 3. You have 2 times 3 minus 5. So that means the acceleration is 6 minus 5. So the acceleration is 1. But look at this one. It gives us the velocity. So in order to move from velocity to acceleration, that means that you're going to have to move here, the v of t. I'm going to circle it. So you're always asking, where am I? And I need to get to here. So you have to take the derivative. So we're going to say the derivative of the velocity is going to give you 6t minus 2. That means we have acceleration. This also equals our acceleration. So acceleration equals v prime of t equals 6t minus 2. We're going to say acceleration is 6 times 3 minus 2, which is 18 minus 2, which is 16. Okay, so that is your acceleration when they gave you the velocity function. Okay, and then look at the next one. The next one, they gave you the position function, so you need to get to the acceleration. So you're gonna have to take the derivative twice. So we're gonna say, let's find the derivative, which is gonna give us negative 3t squared plus 24t minus 45. Then let's take the derivative again because we need to get to the acceleration function. Negative 6t plus 24. So we know this is our acceleration function. Okay. And our acceleration function at 3 is going to be negative 6 times 3 plus 24. Okay. So we have 18 plus 24, which is going to be 22, 32, 42. So it's going to be, what did I just say? 42. Tired, y'all. 22, 32, 42. All right. Okay, and the last one. So there's a lot of information at one time. So, okay, write this down, pause the video. This is where you find out what's happening to the car. So it's still dealing with acceleration because acceleration means like, am I increasing, like speeding up? Am I slowing down? So the way you're going to find out if the particle is speeding up or slowing down is you're gonna have to look at the velocity and the acceleration. So a particle is speeding up, that means it's going faster when the velocity and acceleration are the same sign. A particle is slowing down when the velocity and acceleration are opposite signs. Okay, so let's try some. It says a particle moves along the x-axis. So at time t is greater than 0, its velocity is given by this function. So it gives us the velocity function. It says determine if the particle is speeding up or slowing down. Well, in order to be speeding up, they have to have the same signs. If it's slowing down, they're opposite. So I'm first going to find my velocity. Let's look at my velocity. Let's look at my velocity. So velocity equals 2 plus 11 equals 13. So that's my velocity. But now I need to find the acceleration. So I'm going to take the derivative of the velocity, which is going to be 2. That's it. That means every single number you plug in, it's going to be 2. So when I plug in a 1, it's going to be 2. Well, this is positive, this is positive. So because they have the same sign, that means this is speeding up because they have the same sign. Okay, let's try the next one. All right, so on this one, they gave us the original function. So when you are doing this delta math, you're always going to say, what did it give me? It says the particle speeding up or slowing down. So that means you're going to have to find out the velocity, the acceleration, and compare them. So let's find the velocity. Let's take the derivative of the function. That's going to give us negative 2t minus 4. And then I need to plug in 1 equals negative 2 times 1 minus 4, and give us negative 2 minus 4, which is negative 6. So at 1, it is negative 6. So now I have to take the derivative of this function. So now we're going to say the acceleration is going to be the derivative of this function. So negative 2t minus 4 again is negative 2. So that means the acceleration at 1 is also negative 2. So because this is the same sign as that, that means it is speeding up because of the same sign. Okay, I think there's one more. That might be the last one. Let me check. Oh, and that's the end, folks. All right, hope that's enough to get you guys through the delta math. Later.